All right, today, guys, we're going to talk 3.1 is about exponential functions. Have you guys heard of something growing exponentially? I'm sure you've heard of that before. Unfortunately, COVID is a very good example of an exponential growth. Started off with very small, and the numbers of cases grew rapidly, right? That's what an exponential function is. We're going to talk about growth and decay. Growth means it gets bigger. Decay means it gets smaller. We're going to talk about graphing and stuff like that. But an exponential function, by definition, guys, an exponential function, look, this is what it looks like. There's a base. A is your base. It's a number greater than 1. Greater than 0. Could be a fraction. But if you notice, an exponential function has a variable in the exponent. That's what makes it an exponential. That should make sense to you. Okay? As we move on through here, you're going to have basic questions. You'll have basic questions on your tests and quizzes that just says evaluate. What does it mean to evaluate? What does it mean if you're told to evaluate something? Solve it. Figure it out. So if you were going to do this in your calculator, you would hit 0.5, and then to raise something to a power, there's something called a caret button. It looks like the top of an arrow, like that. And they're telling you to put in 1.2. So 1.2. If I were you, I would put everything possible you can in parentheses. Now on WebAssign, it's going to tell you to round to 3 or 4 decimal places. You have to know how to round. So when you guys evaluate this, what's 0.5 to the 1.2 power? What'd you get? Put the 1.2 in parentheses. So 0.4, what was it? 35, all right. Notice how I put this in parentheses. The reason why you should get in the habit is because when you raise something to like the 7/8 power, when you put that in your calculator, you have to put a parenthesis around it, say 7 divided by 8. If not, it'll raise it to the 7th power, then divide by 8. So in a case like this, you have 150 times 2 to the negative 2.5. You guys have to be able to put things in your calculator. If you're having questions, you need to ask me. Say, hey, I don't know how to do this. I need extra practice, something like that. Because at test time is not the time when you're like, I borrowed this from my friend. I can't help you at that point. So what do you get when you evaluate this? 150 times 2 to the negative 2.5. What'd you get? 26.5. 26.5. What did we get? 26.5. We agree? Okay, so 26.5 whatever. And then round to whatever they tell you to, okay? Now, we're going to talk about characteristics of exponential functions. All right, all of this, all of these words, all are math talk. But we're going to talk through all of this when we talk about domain, the graphs of exponential functions, where they pass through the y-intercept. If it's greater than 1 versus between 0 and 1. If the graph approaches your horizontal asymptotes, those sort of things. So I'm going to talk you through everything. I'm going to expand this to make it bigger, and I'm just going to keep referencing this. First of all, I have a blue graph, and I have the red graph. One of them is exponential growth, and one of them is exponential decay. What do you think the blue one is? Growth. It's growth. We read graphs from left to right, correct? So if you notice, if you put your finger here and follow the graph, you would be going upwards. When you have an exponential growth function, your base, whatever that number is going to be greater than 1. You can have 3 to the x. You could have 5/4 to the x. As long as the base is greater than 1, it's a growth. So if you look here, what is this one? Decay. A decay. This number is going to be between 0 and 1. If there's a negative out in front of it, it means something different. That's a reflection. But your decays are going to have a base that is in between 0 and 1. So 1/2, 1/4, something like that. Does that make sense? So you look at the base to determine if it's a growth or a decay. Now we talk about y-intercepts. How do you find y-intercepts algebraically? You plug in what? 0, 4, x. In this case, where does our x appear? It's in the exponent. If you raise anything to the 0 power, guys, it's 1. So just be mindful of that. When you're finding the y-intercept, you're going to plug in 0 for the x, which is going to be in the exponent, and then you evaluate. Now, we're always going to deal with horizontal asymptotes. In this case, our horizontal asymptotes are 0, right? Your horizontal asymptote is the number or the line, the horizontal line, that your function is going to get really, really, really close to, but not touch. In this case, it happens to be y equals 0. Your horizontal asymptote will change, and I'll show you how. But your horizontal asymptote will also depend, or your range will depend upon that. So in this case, both of these, what's my range for both the blue graph and the red graph? Read from bottom to top. What's the range? Your domain is anything. Your domain can be negative infinity, positive infinity, but what's your range? What do we get really, really, really close to? Y equals what?
0 to infinity.
So it's 0 to infinity. Good. Good, good, good. All right, so we're just going to put that into practice. I'm not going to go through and actually physically graph these because you guys can handle plugging in a table of values. But when you graph, and you're asked to graph by hand, or if they tell you to do it on WebAssign, make a table of values here. Plug in for x and y, two negative numbers, so -2, -1, 0, 1, and 2. Plug it into your exponent and see what happens. Do you notice the difference between these two graphs? What's different? One has a negative in the exponent. It's going to do something to the graph. But if I asked you what the domain was, what are the domain for any exponential function that we're going to talk about? Negative infinity to positive infinity. Your horizontal asymptote is what's being added or subtracted behind your function. Is there anything being added or subtracted there? No. So your horizontal asymptote would be at y equals 0. If I said to you, what's the range? What's my range? 0 to infinity. Good. If I said to you guys, okay, fine, tell me the y-intercept, you'd plug in 0 for x. So what would my y-intercept be? 1. All right. Very, very basic. This is all stuff you guys have done before. It just looks a little different because we're talking about a different function. All right, moving along, moving along. What's the difference in these two graphs?
One's a fraction.
One's a fraction. So what is this one?
A decay.
This is a decay. Perfect. This is a decay, and this is a what?
Growth.
This is a growth. So this one's going to be swooping upwards. This one's going to be swooping downwards. Both of them have a domain of negative infinity to positive infinity. You can plug in whatever you want. What are both of their horizontal asymptotes? 0, y equals 0. Whatever's being added or subtracted to the end. And both of their ranges is 0 to infinity. What are both of their y-intercepts?
1.
1, because when you plug in 0 for x, anything raised to the 0 power is 1. Okay, just want to kind of get you guys, you're welcome to practice this on the graphs and then look at it later. All right, this is a super important slide. There is nothing on this slide that is brand new to you guys. All right, we talked about transformations that you don't have to write this down, but say it looks like this. If I asked you, what are the transformations here? Everybody in here could tell me. What does this negative out in front mean? It's going to reflect over what? Over the x. What does this plus 4 with the x mean?
It's going left.
Left. Good. It's the opposite we think. Left 4. What does this plus 7 mean? Up 7. All right? That applies now. This is a quadratic function. This same thing applies now when we have an exponential function. Do you see here? Here is my exponential function. Agree with me? If you add or subtract something to the end of the function, what does that do? It moves it which way? Up or down. All right, whatever you're adding or subtracting to your function is your asymptote, your horizontal asymptote. Now notice here, where is my plus and minus in this example here? It's in the exponent, it's with the x. So if it's behind, it moves it up and down. If it's in the exponent, it moves it which way?
Left and right.
Left and right. And it's the opposite of what you think. So if it says plus, it's going to move left. And if it says minus, it's going to move to the right. That make sense?
Yes.
Okay. Now, we know what this is. If I have a reflection out in front, we flip over what?
X.
Yep, flip over X. If I have a reflection inside with the X, it's going to flip over Y. Yep, good. Now think about this. If I have something being added or subtracted, multiplied out in front. Do you remember what those were? What does it say? What does it say? It's a vertical stretch or a string. If the number is greater than 1, it's a vertical stretch. If the number is between 0 and 1, it's a vertical shrink or a compression, however you want to say it. Again, that's nothing new. And then the same thing happens here. So look, if I had like 2 times 3 to the x, this is a vertical stretch right here, the 2, correct? Mm-hmm. If I had 1/2 4 to the x,
Shrink.
it's a vertical shrink. Yes, sir.
Can you scroll up a little bit?
Sure. All right, and then the last one we're going to talk about is our horizontal stretches and compressions. Remember, anything with the x, with the exponent, affects our horizontal. So if I have a number that's greater than 1, you would think it's going to do what? Stretch it, but it's the opposite of what you think, so it's a horizontal shrink. If you have a number that's between 0 and 1, it's going to be a horizontal stretch. Good. So what that looks like is if you had like 3 to the 2x versus 4 to the x over 3. Which one of them is a horizontal stretch?
4x.
Yep, this is a stretch. And this is a horizontal shrink. So it's helpful to know that when you're given like 4 graphs and it says pick the one that matches. You could plug in values, but that could take a long time. You might be asked questions on your web assignment that says, tell me what the transformations are. So if you had a problem, let's just do a couple. Say you have f of x equals all right, first of all, f of x, this first one. Is this an exponential growth or a decay? Is that a growth or a decay? It's a decay. All right, this is a decay because your base is less than 1. What does this minus sign out in front mean? It's going to reflect over x. What does the whole number 3 mean out in front? Nope, out in front. It's a vertical stretch. And then in my exponent, I have x plus 1. So where's that going to move it?
To the left.
Left 1. Good. What is my horizontal asymptote right here?
1. I don't know.
Is there anything right there?
No.
So it'd be y equals what?
0.
0. How would I figure out, my domain's going to be negative infinity, positive infinity. I can plug anything in. But how would I figure out what my y-intercept is going to be? Plug in 0 for x. And then you have to evaluate it. You've got to use your brains a little bit. But nothing you guys haven't seen before. Let's look at this one. First of all, growth or a decay?
Growth.
It's a growth. Good. What does this 1/2 out in front mean?
It's a vertical shrink.
Vertical shrink. Good. What is this 3 right here with my exponent? Horizontal what?
Shrink.
It looks like it should be a stretch because it's bigger than 1, right? But anything with the x is the opposite of what you think. What does this minus 7 tell me? It moves where?
Down.
down 7. So what's my horizontal asymptote for this problem? You guys can tell the asymptotes just by looking at the function. What is being added or subtracted?
-7.
So your horizontal asymptote is at y equals -7. What values can I plug in for my domain? Anything in the world. -7. I'm sorry, negative infinity, positive infinity. So my range, this isn't flipped over or anything, so my range is from where to where?
-7 to infinity?
Yep. -7 to infinity. Does it include -7?
Yeah. No.
If you have an asymptote, it gets really, really close, but doesn't do what?
Touch.
Doesn't touch. So does your range include your asymptote?
No.
No, just gets close to it. Okay, good, good, good. All right, so we're going to talk through this one. If you guys want to graph it, you're more than welcome to, but let's talk through these two. What are the differences between the f function and the g function?
The g function is adding 3.
The g function's adding 3. Where is the g function moving?
3 up.
3 which way?
Up.
Yep, 3 up. If it was with the exponent, it would be moving left and right. So if I asked you to tell me a whole bunch of stuff about this function, you should be able to tell me all of this stuff just by looking at it. What is the domain of this function?
Infinity, positive infinity.
It's -infinity to positive infinity, okay? The next thing that's pretty easy to figure out is your horizontal asymptote. Where does this function get really, really close to but not touch?
0.
Y equals 0. It's y equals 0. Whatever is adding or subtracting back here. So if it's a positive function, right, it's not flipped over or anything, what's my range then?
From 1 to infinity.
Not 1. From 0 to infinity, good. And how would I figure out what the y-intercept is?
You said it equal to 0.
That would give you your x-intercept. How would I find the y-intercept? You plug in 0 for what?
For x.
For x. If I plug in 0 right here, what's my y-intercept?
1, 1.
So your y-intercept would be at 0, 1. We figured all that out, guys, just by looking. Right? When I come over here, we're going to do the exact same thing. What's my domain? What am I allowed to plug in for any of my x values? Anything. -infinity to positive infinity. You can figure out your range as well from looking at this, but I think the easier thing to do is find your horizontal asymptote first. This doesn't flip over or anything, right? I don't see any negatives out in front. So what's your horizontal asymptote? What's being added or subtracted to your function?
3.
So your horizontal asymptote is at y equals 3. So what's your range?
3, infinity.
3, infinity. Perfect. What is your y-intercept?
4.
How'd you get that?
Because plug in 0 for x.
Plug in 0. Perfect. Anything to the 0 power is 1, and 1 plus 3 is 4. Perfect. Good. Very good. Oh, look. It's the same kind of thing. What's the difference here? Max, what's the difference in G?
It's moving left and right.
Correct. Moving left and right. Which way does it move if it says x minus 2 in the exponent?
Right.
Moving to the right. Good. Does my horizontal asymptote or my range change for either of these functions? Am I adding or subtracting anything to the back of either of them? No. So my function does not move up or down. So your horizontal asymptote would be at y equals 0. Your range is 0 to infinity. How would you find the y-intercept again?
You said you plug in.
Plug in 0 for x. Good. Good, good, good. All right. I cannot impress upon you enough to remember this, guys. There will be a question on everybody's quiz and test, and somebody will get this wrong. Anything raised to the power of 0 is what? 1. Right now, about something called the one-to-one property. Right, we're going to solve, is there anything in this one? Yeah, perfect. We're going to solve basic equations. It says using the one-to-one property. If they're telling you to use the one-to-one property, this will work, okay? The way that we do this is as follows. Hang on. In order to solve using the one-to-one property, write this down, you need to have bases the same. All right, once we have the bases the same, this is super duper easy. So you just have to think a tiny little bit, guys. Can I break down 3? Can I rewrite 3 a different way that uses a base and exponents? No, right? So I'm just going to rewrite this as 3 to the x minus 2. Can I rewrite 9 as a base and an exponent?
Yeah.
What?
3 squared.
Do you guys agree that 3 squared is the same as 9, correct? Mm-hmm. Do you notice now that the bases on either side of the equal sign are the same? Once you get that to be, you can cross out the bases and set the exponents equal to each other. So x minus 2 equals 2. How do you get x by itself? I'm going to add 2 to both sides. So I get x equals 4. And what is the beauty of getting x equals a number? You can plug it in and check. If I plug 4 in right here, what is 4 minus 2?
2.
What is 3 squared?
9.
That's what we got, right? Okay, so let's look at C. I'm going down to C. I'm just scooting down. They're telling me to use the one-to-one property. Can I break down 6 into another number and an exponent? That'll give me 6.
No.
No. What about 1?
0. 6 and 0.
Well, think about this, guys. Say this out loud. 6 to what power gives me 1?
0.
Correct. Your x here would be 0 because any number raised to the 0 power is what? 1. That will be on a test or a quiz, and some of you will miss that. Don't make that mistake. Anything raised to the 0 power is what? 1. So if I put a 0 right here, what is 6 to the 0 power? 1. All right, now let's look over here. All right, we have to use our brains a little bit for this one. Anybody have any idea? What do you see? I see a fraction. Okay.
Could you do like the exponent be a half by -8 or like 4?
Okay. I like the negative thought. I like the negative thought. Can I rewrite this so it's not a fraction?
Yeah.
How would I write it?
You'd set it the exponent would be -1.
So I would have 2 to what? The negative 1x power. Do you guys agree with that? Negative x? Right? Because how would I make this, if this was 2 over negative, how would I make it positive? I'd move it where? I'd move this down to the denominator, right?
Yeah.
So now if I have, I'm going to make the left-hand side 2 to the negative x. I just brought that 2 to the first power. I brought it up, right? So it became 2 to the negative 1. You guys agree?
Yeah.
So then negative 1 times x just give me, now what can I do with 16? If I set it equal to 16, I still can't solve it because if you're using the one-to-one property, the bases have to be the same. How else can I write 16? Using the base of 2. 2 to what power, guys, gives me 16? 2 to the 4th power. Are my bases now the same?
Yeah.
So what do I do to the bases? I cross them out, and I get negative x equals 4. So x equals what? Negative 4. Whenever you guys see a fraction, what should jump into your mind about the exponent? That it's negative. A lot of times you guys will see like 1 over 25. You're like, I know it's 5 squared, but why can't... Because 1 over 25 would be 5 to the negative 2nd power. Does anybody see a different way that you could have done that? Started off like this. 1 over 2 to the x equals 16. Anybody see anything else? What about if I did this? 1 over 2. Somebody did this first period. And they said 1 over 16. Can I rewrite 16 as something else?
No.
What can I rewrite 1 over 16 as? I could do 1 over 2, right? To what power? To what kind of fourth? To the negative 4th. Are my bases now the same?
Yeah.
So what does x equal here? Negative 4, same thing. Somebody A periods said that they saw it better that way. Okay, that's fine. That's totally fine. But when you have a fraction, what should you think about exponents?
It's gonna become
That they're negative. Good. All right, moving along. I'm going to go quickly through this, but if you look at your calculator, everybody look at your calculators. There is a button. It's on the LN button. It says e to the x. This is the natural base e. Just like pi, if you hit pi, you get 3.1415. E is the same thing. It's already programmed into your calculator. So when you hit e, you get 2.718. That's what your calculator computes. It's on the button that says ln. E to the x and ln are inverses of each other, and we'll get to that in a second. I'm going to go through this quickly, guys. If you're going to evaluate e to the x, you hit second ln, and the e comes up, right? And then you just put 4.2 in the exponent. For this bottom one, you have 125. You hit the ln button, second ln, the e comes up, and then you just put 0.05 times 30. Whatever they tell you to do. I cannot impress upon you enough the importance of using parentheses. If you don't put something like this in parentheses, your calculator will raise to whatever the first number is, then multiply that whole thing by 30. You have to put it in parentheses to tell your calculator what to do. So anytime you're doing more than one thing, if you're dividing, like if you have a fraction and you have to put 8/9, you have to hit 8 divided by 9 and make sure it's in parentheses. This is stuff that you guys just have to practice. And then you round to whatever decimal place that they tell you. All right, quickly. Again, if you're going to use a graphing utility, plug in table of values, all right? This is an exponential function, just uses your natural log. So you can tell me already, what's my domain? What can I use for this function? Any number I want. Negative infinity to positive infinity. What is my horizontal asymptote? No, there is one. What is it?
Oh.
What number is being added or subtracted right there? Y equals 0. So what's my range?
From 0 to infinity.
From 0 to infinity. Good. How would I find my y-intercept?
You plug in 0.
I would plug in 0 for x, right? So if I have e, if I plug in 0 here, guys, your y-intercept is going to be at 4 times e to the second power, correct? You would have to use your calculator for that. If you don't know how to use your calculator, you guys are going to be up a creek. So make sure you have a calculator that you know how to use. But you're just evaluating using your calculator. All right, last thing we're going to talk about. We're going to talk about compound interest. All right, this is very important. You guys will not be given either of these on your test. You're going to need to know these two formulas. I think most of you have seen this before, but we're going to go over it again. When we talk about compound interest versus continuous, all right, compound, they will tell you it's compounded quarterly, yearly, annually, semi-annually, something like that. But in this lovely equation, P is your principal. Write this down. It's your principal. Principal means the amount you start with, all right? If you invest $10,000, that's your principal. Your N is how interest is compounded, and we'll talk about that in 1 second. Meaning quarterly, monthly, daily, that sort of thing. R is your rate. And T is your time in years. Okay?
Specifically years?
Yeah. Mm-hmm. N is how interest is compounded. Now, when we talk about rate, guys, what does it say right here? It has to be in decimal form. So if I tell you that you have an interest rate of 4.25%, is that in a decimal? Yes or no?
No.
But it has a decimal point.
It's a percent.
But it also has a percent with it. You have to first move the decimal point over 2 times to the left. If you don't do that, there is a huge difference between 4.25 and 0.0425. your calculations will be completely off. So you have to make sure that you guys pay attention to those little things. You have another formula that you're going to talk about, and I like to say is my friend APERT. The only time you use APERT is when something is compounded continuously. We're going to go through a couple examples right now. All you're doing, guys, is plugging numbers into a formula, but you have to make sure that you know how to do it. P in APERT. P is your principal, the amount you start with. You hit the E button, the second ln, and then R is your rate and T is your time. So let's look at the next examples. We're going to do these together and then we're done. Remember, N is the way the interest is compounded. So you need a whole bunch of information. You need your P, which is your principal amount. According to this word problem, what did I start off with? $15,000, okay? Then I need my rate. Well, what is the interest rate? 3.2%. Can I use that in my formula? No. What is my interest rate as a decimal? 0.032, correct? All right, so then I'm going to look and I say the time that I'm doing this is for how many years? 2 years. All right, all three of those things are going to be the same in all four of these problems. What changes? What variable changes in these problems? The N. If something is compounded semi-annually, how many times does something happen if it's semi-annually? How many? Twice, 2 times. You guys have to know what these words mean. If something is compounded quarterly, how many quarters are there in a year, or a dollar, or in a football game? 4. If something is compounded monthly, how many months are in a year? 12, good. And then if I see continuously, who is my friend that I think of? My friend APERT. So we're going to work all these out, and I want you guys to practice this in your calculators, okay? Letter A, we'll say. Write down your formula. What is my formula? P times what? Tell me. 1 plus R over N raised to the N times T. Now I'm going to give you a little hint here. When you do this in your calculator, this needs to be in its own parenthesis. But guys, this is super easy. You just have to pay attention to what you're doing. What is the P? What's the initial amount for letter A that I started off with? $15,000. Then I have 1 plus. What is my interest rate? 0.032 divided by N. In letter A, how many times are we compounding this? Twice a year. Good. You see how I close my parenthesis? Now I'm going to close my parenthesis again. And then I'm going to raise it to the N times T. So I'm raising it to the, what was the N value again? 2 times, what's the time that we did? 2. Could you just raise it to the 4th power? Yes. But I'm just showing you exactly how to put it. So in your calculator, do this with me to practice. Do this with me. Type in 15,000, parenthesis, 1 plus, parenthesis, 0.032 divided by 2. Close your parenthesis on that fraction. Then close the big parenthesis, so you should have 2. And then raise it to the 4th power. What do you guys get? All right, we got $15,983.28. Okay. How many of you got that? You know what? Borrow. Do you have a calculator at home? Do you know what it looks like? So, I mean, do you see anybody that has one that looks like yours so you can practice? That's all I'm saying.
The computer calculator?
No, I'll figure it out.
Yeah, computer calculators won't work. iPad calculators you can't use. So, all right, let's look at B. Come on, let's do B together. Let's at least fill it in together. Okay, B. What is the only thing that changes from A to B?
N.
Your N value. So you still have 15,000. We're still starting off with 15,000. 1 plus my rate is still 0.032. And this time I'm compounding quarterly. So my N value is what?
4.
4. And then I'm raising that to the n times t. Well, 4 times 2 is 8, correct? So calculator people, go. What do we get?
17,031.
What do we get?
19,000.
Tell me again, 15,000?
987 and 31.
987.31, okay. If you guys did not get that, I'm glad a lot of us didn't because we're having some calculator issues. That's okay. That's why we're practicing this, because it's not the easiest thing in the world to plug in. What'd you get, 87?
Yeah, 87.
Okay.
31.
Okay, good. Let's try the next one. We're going to do the exact same thing, but letter C is telling us to compound monthly. So I have 15,000. 1 plus, I still have my rate of 0.032, divided by, if monthly is how much? 12, good. Close your parenthesis. And then I'm going to raise it to the n times t. So 12 times 2 is 24. So let's practice that. Go. All right, 15,990 and 2 cents?
Yep.
Like 02, something like that? Yep. Okay. Sounds good, sounds good. Calculator people, you guys got that? Yeah. All right, then look at D. D is continuous. I think of, who's my friend? My friend A pert. So A pert. So in your calculator, P is 15,000. Hit that second LN button so the E comes up, and then in your R times T. So it needs to be 0.032 times the time of 2 years. Put that in parentheses. If not, it'll raise it to the 0.032, then times that number times 2. That's not what you want. Parentheses. What would you get?
15,991.38.
All right, now I want you guys to look at all 4 of our answers. 15,983, 15,987, 15,990, and 15,991. Are those values very far away from each other? No. When you compound stuff continuously, quarterly, monthly, it's all about the same. But what I want you guys to understand is when you take your test, you're going to have at least 2 of these where you have the same values, but you're going to have to like compound daily and continuously. Your answers should be relatively close. I mean, if I make the time 25 years versus 2, it'll be a bit of a difference, but it might be a couple $1,000s. I get answers all the time. The first one is $15,983. Then you do continuous and you come up with $1.3 million. If your numbers are that far off, you should go, wait a second, maybe I forgot to move my decimal point, or maybe I forgot an extra 0. You need to check to make sure that it makes sense. If you're investing $15,000 and 2 years later you have $2.5 million, you're not in any bank in the United States of America. You're in something that you need to share your information because that's really awesome. That's a good investment on your part. But no banks, you're going to earn that much interest in any amount of time. So when you do this, like tonight on your web assignment, there's like 2 or 3 of these. Practice this with your calculator because on your test, there's not a lot of partial credit I can give here if you make a calculator keystroke error. You have to know to move the decimal point for your rate. You have to know which formula to use. You have to know what monthly, quarterly. If I compounded something daily, how much is that? Oh, Lord Jesus. Daily. How many days are in a year? 365. Okay, good. Okay, good. So we need to know annually is how many times a year?
Once.
Annually is once. Semi-annually.
Twice.
Quarterly.
4 times.
Monthly.
12.
Daily.
365.
Okay, good.